Hello everyone and welcome back to the channel. Today we have an exciting topic that can help you become a more efficient and organized Python developer. We're going to talk about Python modules and libraries. And so a Python module is basically a Python script that you can call within another Python script. It allows you to logically organize your Python code, making it easier to understand and use. So let's get started on creating a module. So here I've created a file called module.py. And in here we add two functions. One is called greeting that takes in a name and it returns an F string saying hello to whoever's name we passed into this function. And then we have another function called add, which is simply just adding two numbers together. And so since this isn't a file, we want to be able to access it from a different file. So we can come over here and create a new file and we'll just call it app.py. And in order to access functions from another file or even classes or variables, you just have to say from your file name, so module, and we will import whatever it is we want to import. If we want to just import everything, we can do a star. When you're working with very large files that have a lot of different things that you can import, it's generally not a good idea to do it like this. It's good practice just to import whatever you need from a file. So in this case, we want to bring in that greeting function that we had in the file, and we'll say a comma because we want to bring in something else. We'll add in that add function here too. And so now that we've imported it, we can use it within this file. So we'll go ahead and say print, and we'll have a greeting, and we'll say Zek, and then we will go ahead and run this, and we can see it says, hello Zek. Awesome. Let's do the same thing for the add function now. So we'll go ahead and say print, and we'll add, let's say 27 and 37. And so now we'll go ahead and run this again, and we have 64. And it's that easy. And so once you start looking around some different code bases, you'll notice that there is a very special file in a folder called a init_.py. Having this file in there turns an entire folder into a module. That way you don't have to dive deep into the folder in order to find the specific function that you need. You can just do something like this where it's from the folder name, import whatever it is you need. And I'll go ahead and show you what I'm talking about. So over here, we're going to create a folder called my module. And we're going to go ahead and move this module.py file into this my module folder. And so once we do this, we can see that my syntax highlighting has a little squiggly here, meaning that basically it can't find this module. That's because we've now put it inside this folder. So we could say my module dot to access a file or folder within that. So we can see over here this my module, and inside here we have the module file. That's what's happening right here to access these specific functions within this specific file. And so back to what I was talking about is you will generally see this _init_.py in here. And so this is a very special file, and we can import all of the functions or variables that we want into this specific file to then just be accessed by calling this my module folder. So just like in this app.py file, when originally we had from module import all these things, we'll basically go ahead and take this, add it like this. And since we've added this in here, we can go back to our app.py file, and instead of from module, we can specify the folder name. So we can say from my module, import greeting and add. And you can see my syntax highlighting is registering all of these. And if we go ahead and try and run this, we can see there is an error saying that the module is not found. And that is because when we're running this file here, it's not within this directory of my module. So this init file is saying from module, and it's expecting it to be at the same level of where we're calling the file. So how we can get around this is by putting a period in front of this module. This is saying relative to this current file, which is the _init_. We're going to get this module, which it recognizes it in the same directory. And we will go ahead and import greeting and add, and this will solve the issue. So if we head back over to our app.py file and run this again, we can see that it does work. And so having this period is relative to this current file, but if you were to do something like add a second period, then this would go up a directory. So then we could import something from our app.py or any other file that we have over here. But for this case, we'll just leave it as it is like this, and then we're all good to go. So a Python library is a collection of modules, and it allows you to perform many actions without having to write your own code. Python does have an extensive ecosystem of different libraries. There are quite a bit of built-in libraries within Python, and there's a lot of external libraries as well. One of the built-in ones is the OS library. We can use this library to interact with the operating system, like getting the current directory, operating system information, changing directory, listing the directory, and many more. And so for this example, we'll go ahead and import OS. So we can go ahead and access the library relating to the operating system. And as an example, we'll go ahead and say os.cpu count to find out how many CPUs this computer has. So whenever we go ahead and run this, we can see that it has 24. We can also get the current directory of the file by calling os.getcwd. And this will get the current working directory. So meaning if you run this file, but you call this function within a folder, it's still going to print the current working directory of the file that you ran from. So we can go ahead and run this and we can see the path that it brings us. So we can also change directory by calling os.chdir, so change directory, and we specify a folder path for it to change to. So in this case, I'm doing ./test. And I don't have this file here, so if I try running this, it will throw an error. But if we go over here and create this folder, test, and we run this again, you can see that it didn't throw an error. So just to verify that we've made it inside this folder, we'll go ahead and print the current working directory again. And whenever we go ahead and run this, we can see that it has changed to this test folder. Another pretty useful one is os.listdir to list everything inside of the current directory. So if we go ahead and run this, we can see that it prints app.py, test, and this pycache, which is everything that is here. And this is just an example of one built-in library within Python. There are many more that you can find online, but we'll go ahead and get into some external libraries. And so in order to install these external libraries, you need something called pip. And so pip does stand for Preferred Installer Program. It installs packages from the Python package index. You can access the website version of this going to pypi.org. So you can find out if you have pip already installed just by typing the command pip, and we'll do -- version. And we can see it does give us a little output here. If you get an error saying that it's not found, then you need to install pip. And you can do that by typing python-m ensure pip -- upgrade and press enter. And this will install pip for the command line for you. But once that's installed, you want to go ahead and open up a new terminal. So we'll go ahead and close this one and press Ctrl tilde to open a new one, or Command tilde on Mac. And then you should be able to type pip -- version and then have it pop up here. So one example that we get started with is numpy. And numpy is a Python library that's mostly written in C to be really fast for numerical operations. And so we can go ahead and come down to the command line and type pip install numpy to go ahead and install this external package and press enter. Yep, and I already have this installed, but you will see it install for you. But once we have that installed, we can go and come up here and we'll import numpy, and we can say as np to give it a shorter or different name. This is very useful if you have conflicting modules, so modules that have the same name, or if you just don't want to end up typing out all of this. And so we can go ahead and create an array with numpy, and it's a little bit different than making a list in Python. We'll say np.array, open and close parentheses, and then basically make a list inside of it. So we'll have 1, 2, and 3, and then we'll go ahead and print out the array. So we'll go ahead and run this and see that it basically just prints a list, but you can see there's no commas in between. This is just how NumPy is formatting this array to be printed out to the console. But we can go ahead and perform a numerical operation by saying array.max to find the max in this array. And whenever we run it, we can see that 3 is the max. And we can even rewrite this to be a two-dimensional array. So we have an array of a list of 1, 2, 3 and a list of 4, 5, 6. And we'll go ahead and print it and print out the max from this. So whenever we go ahead and run this, we can see that it found the max number inside this two-dimensional array, and it was 6. Another very popular library is matplotlib, and we use it for data visualization. So creating graphs and other kinds of visualizations for data. And so we can install this by coming down to the console and typing pip install matplotlib and press enter. And if you don't have it already installed, then it will go ahead and install everything. And for this, we're going to import matplotlib.pyplot as plt because we don't want to type all that out. And here we're going to call plt.plot. We're going to plot some data having the x coordinates and the y coordinates. So once we do that, we can go ahead and say plt.show to go ahead and show us what it looks like. So whenever we go ahead and run this, we can see that it popped up a graph with the points on it. So that's really easy. So there you have it. Modules and libraries are crucial tools for any Python developer. Make sure you like the video if you found it helpful, and don't forget to subscribe for more awesome Python tutorials. And I'll see you in the next one.